Hey everybody, so welcome to CS302 Summer 2022 Session 3. And for our first assignment, we're going to implement a sorting algorithm, which is brick sort, similar to bubble sort. And of course, to make things complicated, we're going to use a doubly linked list to maintain sort of our list of elements that we're going to be sorting. So let's first go over just basically this class, this linked list class first. And then once I cover that, then we'll go over how to implement brick sort in main. So the first thing I'm going to go over is all we have is class LL, and we're going to have a template. So right now in this program, our linked list, we're going to be sorting integers. Obviously, our template will be int, but we're going to actually basically just have a template just to practice templated types as well. So anyway, as we know from CS302, a linked list will be a set of nodes, and then a struct node is going to be one node in our linked list, and every node is going to contain some data field, which in this case for our assignment, this type t is going to be int, and data is going to be integer is what's going to store. Then we have these 2 pointers, a previous and next. So since our linked list, the orientation of how we think about a linked list, we always go from left to right. So every node has sort of 2 directions. So it's a doubly linked list we're going to be implementing for this program. And the next pointer is going to point to that right node in the linked list. And then prev or previous is going to point to that left node in the linked list. So that's our first starting point. Now, Iterator, I'll go over this in a more visual representation a little later on, but I'll skip this. But we're going to have a class Iterator defined within our class linked list. So we'll go over that Iterator content later. So the first thing we'll do right here is we'll go over the basic functions. So we're going to have essentially our constructor LL, but actually I'm going to first go over our private members of our linked list. So we have our node star head, node star tail. So basically, we're going to have these 2 pointers. So head is going to be a pointer that points to that first or leftmost node, that head node of our linked list. And then node star tail is going to be a pointer that points to that rightmost node or that tail node in the linked list, that end node. So we have that part. So that shouldn't be anything too complicated. So now with our default constructor, we're going to simply just set, so this constructor simply sets head and tail both equal null or null PTR, just initialize an empty linked list. So nothing too fancy there. Now this constructor is going to be our deep copy constructor. It's going to be this other function, this operator equals, going to be our deep assignment operator. So refer back to your CS302 notes on that. So remember, you're passing in, so in this first constructor, this constructor right there, that deep copy constructor, it takes in a linked list object. You're going to simply do a deep copy of it. So you have to go through each node one by one in that linked list you're passing into this constructor, and one by one, just you have to allocate a node into your this pointer, and then copy the data field of a node from this passed in linked list into that this linked list. So basically, you can use actually tail insert within this function one by one. Just do a tail insert every single node from this copy into this linked list. And then for the assignment operator, same idea as a constructor, except you have to do one extra sort of level. You first have to make sure you deallocate this linked list, because remember, when the equals operator is being used, or assignment operator, sorry, there's a chance that left-hand side linked list already contains a linked list of nodes. So you want to first deallocate that before you do this actual deep copy. And of course, you have to check for a self-assignment as well, which I believe I have here in the notes. So I'm using the dark theme here in the video because it's easier on the eyes, for me at least. My eyes aren't burning from this dark theme. I also have a light theme version of the PDF as well, but I like to use a dark theme for the video. So anyway, let's see, there it is. So you want to first go ahead, you want to do a self-assignment. So remember how that works in CS302. You first have an if statement. So if this if this does not equal to ampersand RHS. So we want to make sure that the left hand and right hand side objects aren't the same. If they are, there's no point doing any work at all. So just remember that from CS302. First check for a self-assignment. If the left hand side of this object and RHS are not the same object, then of course you want to first deallocate this object. And then do the same exact, you can literally copy and paste the code from this copy constructor to do a deep copy. So these won't be used in main most likely, but we're going to have a test script in CodeGrade. That's going to check to make sure you did correctly implement your deep copy constructor. So you have to, of course, implement this because we're going to test for it, but it won't be used in main. They're not going to be worth too much points, actually, but it's still proper to implement them for a class that has a pointer. And then, of course, our destructor is going to simply do a deallocation of our linked list. So it's remember from CS202, a linked list deallocation is sort of like playing Pac-Man. You just sort of do a head deletion one after the other until every single node has been finally deleted. So that's the very basic stuff for this linked list. Now we'll go into the more complicated stuff, I guess, the head and tail insert part next. Okay, so let's go over to head insert first. So this function basically is you're going to insert a new node into your linked list, and that new node's data field is going to contain this item right there. And once you allocate the node, you want to insert it to the front of the linked list. So let's go ahead now. I'll just sort of draw an example just to give you an idea of how you want to approach this program. Let's go to my one node over here. So let's say we have a linked list allocated like this. So I say llint list. So list is going to be a linked list of integers. Okay, so obviously when you call this function, you might just do something like list dot head insert, and I'll just say 7. So right now 7 goes to the front of our linked list. So okay, so what happens here is within the function body, you want to create a temporary pointer. So I'm going to call this temp for right now. I'm not going to write the actual code for this, but I'll let you kind of figure this out in case if you forgot. So you first have to create a pointer, so you can say node star temp. And then you want to say temp equals new node. And what that does is going to allocate a node, basically. And this node will have these 3 sort of fields. Obviously, this field right there will be your previous, data, and next. So of course, temp is going to point to this node. And of course, you're going to set temp arrow. Remember how that works. Remember, you can say temp arrow data equals item, which will assign 7 into that data field of that node. And of course, for now, you want to maybe set this node's temp previous and temp next both to be null for right now. Okay, so what's going to happen is the following situation. So let's say if our list is initially empty. If a list is empty initially, well, then what's going to happen is you're going to set the head and tail both equal to this node. And the reason why is because if you only have one node in your linked list, that's going to be your front and your back at the same time, right? So that's going to be one case you have to deal with. Well, what if, you have empty linked list? And the way you can tell is, well, if head equals null, and also let's say if head and tail both equal null for that matter, well, then that means your list is obviously empty. If head and tail don't equal to null, then obviously there is at least one node in your linked list. Okay, so that's not too challenging. Now, let's suppose for a different case, what if we have a case where, let's say we have, I'm going to have my head over there, and maybe I'll have, let's say, tail over here. We have several nodes. Let's say we have 3 nodes. This is a very bad picture, but this is just giving us an idea of how this would look like. So we have this, and of course head and tail. So remember, make sure that head node's previous is always null, and then tail's next is also null, just to be safe like that. So anyway, in this situation, if we have several nodes, then what you want to do is you want to actually update temps next to point to head, because this node that contains 7 is going to be your new head node. And of course, you want to set heads previous to point to that node. Then of course, then you want to set head to point to this new node. And then basically you're done. You have your head insert done. Now this is your new head node. So maybe I'll redraw this. So now it's like this basically. Then once you're done, you can stop right there with that function, because if you wanted to, you could set temp equal to null. But since temp is a local variable defined within this function, it's going to be destroyed once the function is returned from the function. So we're done at this point. But do not say delete temp at this point. If you do that, what will happen is you're going to actually deallocate that node that temp points to, which means now you have a busted linked list. So you don't want to say delete temp, rather just say either temp equals null or just don't do anything, because once you return from this function, temp will now be destroyed. So that's going to be the general head insert for this linked list class. Now for tail inserts, the same thing but different. So I'm going to leave that to you, but it's the very same logic, except you can insert at the end. So you have to create a new node. Of course, you're going to create a pointer temp equals new node, and you have to make sure that the tail points to that new node. And of course, that new node's previous points back to tail and so forth. So that I'll leave that one just to you for right now. So you can kind of work on that. And then I guess now I'm going to go over the iterator class content. And then we'll go into this last function, swap nodes, that beast of a function for this class. So let's go over the iterator stuff now. Okay, so for the iterator class, the iterator is going to just be really just a beefed up pointer, if you will. So it's just going to basically allow us to traverse the linked list in main without exposing any pointer data, because the node stuff is actually kind of, if you look at this right here, the node is actually a private member because there's nothing here, so it's private within this linked list class. So you can't really use pointers in main to directly traverse through a linked list. So you're going to have to basically use iterators to do this. So an iterator has a private member called node star current. So current is going to be the field within the iterator that's going to allow you to be able to sort of point to a node in the linked list. So this friend class LL right there, what that really does is it's going to allow the linked list class. So if you declare an iterator variable within a linked list class function, you'll be able to access a private member, which I guess if you're going to be using iterators within the linked list class, but you're not going to have to do anyway, but if you are going to do that, then you'll be able to directly access the current field within the linked list class, but that's just for that. So anyway, basically iterator, this default constructor, is going to just set current equal to null. This constructor right here, second one, will take in some pointer, assign that pointer to current. So pretty simple. Now at operator star, this is going to behave like a dereference operator. So what does dereference do in C++? Well, it's going to return the data that the pointer points to. So in this case right here, if the star is being used on iterator object, it's going to retrieve that data field of that node that the iterator points to. So of course I'll draw an example of how that's going to work but just to give you an idea here. Then a plus plus and minus minus. So these are going to be two postfix operators. So this int parameter right there is only there just to tell this compiler that plus plus is going to be postfix. So you're going to have an object of iterator type, and then plus plus comes after, not before. So for minus minus, same idea. So plus plus, what it will do is it moves the iterator over to the next node in the linked list. So in this function body, you would just say current equals current arrow previous, and then of course return star this. That's all you have to do for plus plus. Minus minus is going to be just simply current equals current arrow prev, and then return star this. So you're simply going to move the iterator to the right or to the left based on if you use plus, plus, or minus minus. And then for the last two comparison operators, for equals equals not equal, well, you're going to simply compare the iterator's current pointers. So you're going to make sure, so in this case, for equals equals, you return true if the left-hand side iterator object's current equals to the right-hand side iterator's current field. So you're simply going to have this arrow current equals to RHS dot current. If they have the same address, then return true, else return false. And not equal is the same thing, but in reverse. So let me go to the actual implementation right here. Yes, so you have RHS object. So you have to do star this arrow current equals RHS dot current. Do that comparison. If they're the same address, returns true, else return false. And then not equal is the same idea. So that's the Iterator class content, but of course I will go over examples so you can kind of see how Iterator works. And the last two functions, or before I go over to swap nodes, we have begin and end. So begin is going to be a function within the linked list class that simply returns an iterator object whose current contains head. So within this function body begin, you can create an iterator variable, set the iterator variable's current equal to head, and then simply return that iterator variable. And then for end, same thing, except set that iterator's current field equal to tail. So let's go ahead and show an example of how this would actually work. Let me go back to my OneNote notebook over here. So I already have a pre-drawn example here of a linked list. Let me go ahead and actually just maybe add some values. Let me say I'll have 5, 3, 2, 1, and 4. I think I'm going to erase all of this. I have some space to, I'll probably just do this instead. Have some space to draw stuff. So let's say we create a linked list object in main, and we did a bunch of tail inserts. I did tail insert 5, then 3, 2, 1, and 4. So we have this linked list. So right now, imagine we're in main. I mean, I'll put into main even here just to like really make it very clear that we're into main right now. And we just simply created a list object. And we did several, I'll just, show, we essentially did this. We first did list dot tail insert 5. Then we did, several more. We did tail insert 3, then tail insert 2, then tail insert 1, then tail insert 4. So we end up having this linked list right here. I'm going to move this down a little bit so I can draw some pictures later on. Like that. Okay, so let's suppose I want to be able to traverse through this linked list for whatever reason, maybe output the node values. I don't know, something simple like that. So what I could do is create an iterator object. So I have to create it like this. This is kind of bizarre code, but anyway, just follow it. I think it's a capital I for iterator, I believe, in this program. So I'm going to go ahead and use capital I, iterator IT. And I guess I could also create another iterator as well. Just to be able to loop through this, if I were to do that. And I'll call it the end. And, okay, so we have these iterators. Okay, so let's say I want to go ahead and I want to traverse through this linked list. Okay, so the first thing I'll do is I'll say it equals list dot begin. What this does is list.begin, as I mentioned a second ago, it returns an iterator object in such a way. So it returns an object iterator that it contains the head pointer. So this function call simply returns an iterator, and that iterator's current will contain the head. And we're going to copy that into this it variable. So essentially, at the end of the day, it is going to point to that first node. So I'll draw this up over here. So we're going to have it like this. It is going to be an object, and it contains this current field within it, and it's going to point to that node. That's how we can visualize it. So that's what's going to happen right there. So now, if I want to maybe output the node, output the data, I can go ahead and just, of course, use standard. Actually, I'll be more careful. Standard cout star it, and then slash n to output a new line. So also to just before I move ahead, So since Iterator is a class defined within the linked list, we have to use linked list int, and then we have to use the scope resolution operator because we have to be able to access Iterator. Iterator is defined within the linked list class. We have to use this notation to declare iterators, just because of the fact that it's declared within the linked list class. Okay, so I'm going to go ahead and see out star it. So a star symbol, star it, what it does is going to retrieve the data field. I'll just right here in blue. It retrieves that 5 basically. So what star operator will do is simply return current arrow data, because since current points to a node, current arrow data is going to be that value. So in that function body, operator star, it returns current arrow data. So if I say star it, it's going to retrieve 5. So it outputs 5 right there. So now, if I wanted this iterator point to the next node on my linked list, I would just say simply it plus plus. So this function that you define in your linked list class, what it's going to do is, remember, just to recap, this function body just says current equals current arrow next. So this it plus plus is going to simply, end of the day, it's going to have this pointer point to that node next. So in main, we'll be allowed to actually traverse the linked list almost like using a pointer, except the pointer data is hidden, but the iterator has a flexibility to allow us to traverse this linked list. And now if I go ahead and say something like standard cout star it, and of course I'll put the new line. Well, now in this case, since it's current field contains this address, it points to this node, so star it is going to retrieve the data field of this node, which contains 3. So it outputs 3 in this case when I say star it like that. So hopefully this is giving you an idea of how the code for Iterator works and how it's used in main. So hopefully the code, so implementing the Iterator class hopefully makes sense, because this really is not, so most of the functions in Iterator are actually pretty simple. And of course then we can do it minus minus, and what that does is going to move Iterator to the left by 1 node. So then it would just simply set current to point to the left node of where we were a second ago. So the plus plus will move the iterator to the node to the right, and minus minus moves it to the node to the left. That's really all there is with iterators. So that's all there is to iterator class. So basically I covered all the functions in our linked list, but now here comes our dreadful swap nodes function. Let's cover that next. And before I cover the swap nodes, I forgot to do one thing. So I'm going to go over how to iterate through this linked list. So let's say if I want to have a loop to iterate through it, you can use a while or a for loop. I'll use a for loop for right now. What you could do is have something like for it equals list dot begin, and it does not equal the end, and it plus plus, and then of course we can just do standard cout star it slash n like this. So it will first set it to point to that first node, and then the end. So since we created this iterator, and since we use a default constructor, the end, the current field contains null. So once it does equal the end, that means it contains null, so we'll stop looping. So basically, first set to beginning, we output the node, and we increment iterator by 1, and eventually once it does equal the end, so once it's current contains the end's current, so I guess the end's current is null, so once it's current equals null as well, then this condition will be false and it will break out. So that's how you can traverse using a for loop. With a while loop, I guess, wouldn't be so much difference. You could just say it equals list dot begin, and then while it does not equal the end. We'll just go ahead and output the node's data field. And then, of course, the last statement will be just it plus plus. So the same thing. So it's up to you if you want to use a for or while loop to iterate through. But I believe in the PDF it has it as you cannot write a counter control loop in your program. So neither of these two are really counter control. Even though a for loop is being used here, it doesn't go on a counter. Really, once it hits the end of the list, it's done. So really, neither of these two loops are counter controlled. So just kind of putting it out there. Okay, so let's go ahead and now talk about the swap nodes function. All right, so swap nodes. Now, luckily in this program, you're going to only have to swap nodes between two adjacent nodes in the linked list, which makes this swap nodes a little bit simpler to write. So anyway, you might have encountered this in CS302, but it's okay. At least we're kind of, we're recapping linked list contents. So in this function, swap nodes, you're going to be passing in two iterators, which point to two nodes in the linked list, and you want to swap those nodes. Now, you don't want to swap just the data fields between them. You want to actually swap the actual two nodes, the two physical nodes. You want to swap the locations, I guess you can say, their geographic locations in the linked list, because that's actually the most efficient. So that's efficient. I mean, as in, that's the kind of benefit of a linked list over an array. So really, swapping the two data fields versus just swapping the geographic location of the nodes linked list is actually asymptotically, so you learn about that more in this class, they're actually both constant in runtime. So the benefit of doing this is actually, let's suppose, for example, data fields of our two nodes were not just integers. Let's say the data fields were vectors. Then doing a swap of two vectors would take a more than constant time to copy two vectors over. So swapping the actual node locations is actually more efficient in that case. So if you have a bigger data value stored within each node. But anyway, let's go over the actual sort of the pseudocode for this algorithm for the swap nodes function. Let's go back to our one node over here. So let's suppose we have the same linked list from before, and I'm going to create two iterators. So I'm going to say int iterator. Hope I spelled that right. Iterator, and I'll just call this maybe I, j, like this. I think I'll move this down a little bit so I have room to draw pictures out. Yeah, it should be good. Move it down a little lower. Okay, so let's say I have I equals j equals list dot begin. So I'm going to make this a little bit shorter, shortcut version. So we're going to have I over here, and we'll have, maybe I'll use green here, so then j, say both point to the head. Okay, so I'll move j over twice and move I over once just to go over this example. So we're going to say, I'll say j plus plus and then j plus plus. So it's going to move j over twice. So j essentially is going to move over once and then twice. So j is going to be pointing to that node. So remember, j is an iterator, not a pointer. So j's current field will actually point to the node that contains 2 right there. Then I'll do I plus plus right there. So then I moves over to the next node in the linked list. So then I will be right here. Like this. Okay, so then I'm going to say list dot swap nodes I comma j. So within the function body, it1 will be I and it2 will be j. Doesn't really matter, but we'll do like this. So within this function body, I'm going to put really in parentheses. This is going to be it1. This is going to be it2 because we're going to look at the actual function parameters like this. So Just to repeat myself, we don't want to just simply copy this over with this. That would be too easy, and also at the same time, if the data fields were very large within each node, then copying the data fields could be very time consuming. So using a linked list is efficient, as then we can swap these nodes, which will be a constant runtime, which is really nice. So we have to swap these two nodes. So what we're going to have to do is within our function body, very likely we're going to have to create some additional pointers. So I'm going to create maybe a pointer here. I'll call, actually you can create pointers. So in the function body, you can create pointers instead of iterators, because if you're inside the class, there's no point to use iterators. So just use pointers, I guess you can say. So you can create a pointer, call it maybe node star. And I'll call it maybe just, maybe I'll call it sort of, maybe I'll call it left. Then I'll have another pointer, node star, and I'll call it, I'll use lowercase, right. And you want to set left to point to the node that's the left of it1.currents left. You want right to point to that node right after it2. So, not so complicated to do that. So you need to maintain these elements, of course. So, and of course, you also can even create a pointer within this function. Maybe just a pointer points to this instead of using iterators inside the function body, but it's up to you though. So now what we have to do is several lines of code, or several things we have to take care of. So this is actually, if you've ever seen SpongeBob, this is actually similar to that one scene where I believe when Mr. Krabs was dating Mrs. Puff, and he was drawing these imaginary circles like, we're not talking about this, we're not talking about this, we're talking about this. And the SpongeBob later in the episode goes crazy with this, and he just, like a mad person, starts drawing, kind of air, lines or whatever. So it's going to be similar to that. So what you have to do in this program is first, well, not just any order you want to do this in, but you want to go ahead and you want to first have it like this. So you want to actually take these two nodes physically. You want to really take this node and put it here, and this node you want to go ahead and put it over here. That's our goal, basically, what we're trying to do. Except, unfortunately, it's not as simple as just using a one node pen and just lifting these two nodes up like that. So let's go over how it's going to actually work. Okay, so what we want to do is, well, if let's say this node where I is pointing to, so 3 is going to be in 2's location, then we want to, of course, set this node to point to that. So we know that address because node star, or so it is right node, contains the address, so you can, of course, set this address to point to that. So it's simple pointer assignment. And of course, in this case, then we want to do is, well, this node right here contains 1. This has to point also over there like this, because since 1 will be the right side, then this node's previous has to point to this node right there. So it's just going to be another pointer assignment. And after that, what's going to happen is you're going to want to set this up where now J is going to point to, it's going to be in I's location. So then this node its next is going to be to that node. And then this guy's previous is going to be this node. We're looking at a really bad picture right here, but yeah, that's the truth of it. And then of course, what we want to do is you have to set this node that's to the left of 3, its next has to be pointing here. And then of course, 3's previous has to go back over here. So this is very tangled up, but if you were to untangle this, the result would look like this. Let me go ahead and actually just copy this picture and redraw it. But these wires are definitely tangled up. But you have to essentially rewire this linked list. I'll put it down over here actually. like this. So the result, this is just really a hideous sort of drawing, but anyway, I'm going to go ahead and sort of draw this up. Just, you know what, because I'm in too deep now, so I have to draw this now. So here's the result we're going to have. I'm going to redraw all those lines actually, so it'll make more sense. So we had this, I believe. Let me just double check with my older picture. Yes, we have this now. So they are swapped. Okay. So really what happens is this. So we have this scenario. If I were to redraw this, that's how this looks. Let me sort of kind of, maybe I can copy this image also, so we can kind of compare it sort of side by side, if you will. So here's our first hideous drawing, but that's after we rewire it, it looks like this pretty much. So we have it where this node 5 points, actually I think I should have kept it color coded the same. Oh, I'm sorry about that. I don't want to recolor this now, but see, 5 points to 2, and 2 points back to 5. 2 points to 3. 3 points back to 2. Then 3 points to 1. And then 1 points back to 3. So that's what we have. And actually, my mistake here is the following. So actually what happens now is this is what we have at the moment. Maybe I'll recolor these so it's more consistent. So I'll recolor it. So we have this. But by sort of wiring this linked list, and of course, imagine we rewire it and we take the head and tail and sort of pull them apart, we kind of redo this linked list. This is how we're going to have. This is what we should have at this point. So now we were able to successfully swap these locations. So after we're done with this, now the last thing we have to do is make sure that we set IT2's current to actually, IT2.current has to point to this node, and IT1's current has to point to this node. Because if we don't, what will happen is, so remember, IT1 was originally pointing to that second node, and IT2 was pointing to that third node originally. Well, after we swap, we want to make sure IT1 still points to that quote-unquote second node in the linked list, and IT2 will still point to that third node in the linked list. So then J also, so since we're using reference parameters in that function, J will also point to that node. So we go back to main, I and J will now point to that same sort of node, the same position in the linked list. So I will still point to that second node, and J will point to that third node. So you have to, of course, swap IT2's and IT1's current pointer fields to make sure that IT1, IT2, and of course, respectively, I and J point to that same location in the linked list. So I guess since I and J, or IT1, IT2, will always be adjacent nodes, and of course, when you go ahead and call this function, you can, of course, pass in the pointers, or sorry, the iterators in such a way where that IT1 will be that left node, and IT2 is that right node. So you can make assumptions like that to make this a bit easier. Well, whatever that means. And of course, another thing that they make sure of is, well, what if IT1 points to the head and IT2 points to the tail? Then let's say for example, what if IT1 was the head node and IT2 was that second node? After we swap, the head node, the head pointer actually will move with that node. Kind of like over here, we swapped them, I moved with that node. So if let's say we were to swap the head with the second node, what would happen is that head would now be pointing to that second node from now on, not to that first. So you have to make sure you set head back to the original, back to the new head node. Because let's say you just look at this picture up here. This is all a mess now. Let's say if I want to go ahead and do another swap. I want to swap 5 with 2, let's say. then what will happen is 5 will move over here and 2 will move into the first positions, but head will still point to that node 5. So head is not going to be that head node anymore. So you have to make sure you reassign head to that to the new head node, that it makes any sense. So if you swap 5 and 2, then 2 is that new head node from now on. So you have to also check for that as well. So I think that covers everything. So, of course, I would just say, draw an example linked list like I did here, and just sort of draw it out, and step by step, as you sort of update pointers, write the code simultaneously, or write the code in parallel as you draw this out, because I think that'll help you a lot. Just draw it out first, make sure you kind of understand which nodes have to be adjusted, and then of course write the code out after that. So now we're ready to go over the actual brick sort algorithm for main. Alright, so now we're at the last part, which is going to be the brick sort algorithm. I'll first go over the input and output to this program. So the input is going to just be, well, you're going to read in from the user a file stream, or sorry, a file name, and you're going to use a file stream variable to open it and read a file which contains a set of numbers, one number per line. So you can very easily just read a number one by one, and for each number read, you just do a tail insert into your linked list to build your linked list of those numbers. Pretty simple. And the output, of course, you have to simply just output the sorted lists, and basically make sure you put a space in between or some type of separator between each number. So for code grade, it'll be easy to verify the output. So it could be a separate line or a space or a tab, but some way to separate each number for the output, so code grade will be able to just compare the solution with your solution. So for the brick sort algorithm, I actually have a link right there. Of course, you can go through that, but I'm going to go ahead and use here on OneNote and go over how brick sort is going to work. Let's go to the OneNote page. Okay, so let's go ahead and consider this list right here. So clearly this list is not sorted in ascending order. So we're going to have to run this brick sort algorithm. So in this algorithm, if you look at that PDF and it has the link for on Geeks for Geeks, you'll see that you have these odd and even phases. So the first phase you're going to have is going to be an even phase. So let me go ahead and actually first just set this up. I'm going to have one pointer. I'm going to have maybe this pointer, I'll call it C, will point to that first node. So I'll go back and go over what the C is going to actually do. But right now, the important part is we're going to have these two iterators, I and J. So I guess C is also, so these are all iterators. I and J and C are iterators, and head and tail are pointers, but they're private within the linked list class. So then what happens is in this even phase, we're going to have I start at that 0th element, that first element, if you will. And we're going to compare the adjacent elements. So of course, we can do star I and star J to retrieve the 5 and 3 respectively. And so if the J value is in fact less, you have to swap these two nodes. So of course, when you swap these two nodes, what happens is, at the end of the day, you're going to have 3 over here and 5 over there. That's going to be the result. Now, of course, your swap nodes function will be called right there on those two iterators. And of course, remember, you're going to actually geographically swap those two nodes in the linked list. But I'm just sort of showing you that's going to be the end result. So you're not going to actually just swap the data fields, but you're going to swap those two nodes in their locations. Now you have this situation. So then in your next iteration, so next iteration within this inner loop is I and J is now going to be like this. So you have to move the iterators over like this. Now I points to that node, J points to this node. So same idea, you go ahead and compare the two nodes, and you see that, okay, the J element is in fact less. So you're going to have to go ahead and call swap nodes and pass an I and J. And of course, the end result is going to be like this. Now you're not going to, again, not going to copy data fields, but the result will be this. And at this point now, I and J can't move any further, because if you do this, the J will be beyond the array or the linked list bounds. So that's going to be done. You're done with your first phase, that even phase. So then what happens is now the next iteration, so that right, what I showed you was the contents of that inner loop. So now the outer loop is going to run. You're going to have to run another phase. So you just did your even phase. So now you're going to do an odd phase. But you will first move this C over to the next node. And the reason why is because you're not going to use a counter-controlled loop to do this. What you're going to do is that C iterator is going to tell you essentially, if C is not null, then you haven't run enough number of iterations for the outer loop. So what happens now is not as C moved, now you're going to be in the odd phase. So really the changing of phases is very simple. You can have a simple Boolean variable and have it flip after every inner loop iteration. So now we're going to be in odd phase. So now what's going to happen is I starts off over here and J starts off over there. And they do the same exact work. So you check, well, the J element is less, you have to do a swap nodes, and result will be 1 will be here and 5 is going to be there. And we move I and J over 2 spots over. And then we have to again, compare. In this case, since star J is 4, it's not less than star I, then we're done. So we finish this inner loop once again. And then this C counter moves over to the next element in this linked list. And now we're going to be at an even phase. Now I will be set here, J will be set there. And we just simply do the same work over and over again. So this inner loop will have I will either be at the first node or the second node, depending on whether it's an even or odd phase. So really, the starting location of I will vary. Either it's going to be at the first node or that second node. If it's an even phase, start here, odd phase, start there. And even and odd phases basically just alternate with each other. So what happens every time you run a phase, this C iterator moves to the next node. And eventually, once C goes through the entire list, and then C eventually, the iterator C points to a null eventually, then we're done. So that C iterator is going to be used in the outer loop. It's going to almost behave like a counter control loop, but it's not really counter controlled because we're not going to have it where we have an integer variable less than n in an I++. It's going to actually just have this iterator move until it hits the end of our list, and at that point we're done. So this is going to regulate our outer loop. The inner loop portion will have the I and J's move accordingly. It's always going to sort of move 2 nodes over and then compare the adjacent values. And eventually, once C equals null, the list should be sorted, is the idea. So of course you can watch the that link, look at that link on Geeks for Geeks. But this is sort of a nice, or hopefully a nice visual example of how to incorporate iterators with this. So again, no counter control loops are allowed. This is sort of the bypass. C is going to be the outer loop kind of controller, and I and J is going to be that inner loop sort of controller, if you will. So I hope this video helped you out. So I guess happy coding, and as always, take care, guys.